Thank you for the visit. SciQ is science made simple for the rest of us. Enjoy. AI has been part of our imaginations and simmering in research labs since a handful of computer scientists rallied around the term at the Dartmouth conferences in 1956 and birthed the field of AI. In the decades since, AI has alternately been heralded as the key to our civilization's brightest future and tossed on technology trash heap as a harebrained notion of overreaching propeller heads. Frankly, until 2012, it was a bit of both. Over the past few years, AI has exploded, and especially since 2015. Much of that has to do with the wide availability of GPUs that make parallel processing ever faster, cheaper, and more powerful. It also has to do with the simultaneous one-two punch of practically infinite storage and a flood of data of every stripe, that whole big data movement, images, text, transactions, mapping data, you name it. Back in that summer of conference, the dream of those AI pioneers was to construct complex machines enabled by emerging computers that possessed the same characteristics of human intelligence. This is the concept we think of as general AI. Fabulous machines that have all our senses, maybe even more, all our reason, and think just like we do. You've seen these machines endlessly in movies as friends C-3PO and Foe, the Terminator. General AI machines have remained in the movies and science fiction novels for good reason. We can't pull it off. At least not yet. What we can do falls into the concept of narrow AI. Technologies that are able to perform specific tasks as well as, or better than, we humans can. Examples of narrow AI are things such as image classification on a service like Pinterest and face recognition on Facebook. Machine learning, ML, at its most basic is the practice of using algorithms to parse data, learn from it, and then make a determination or prediction about something in the world. As it turns out, one of the very best application areas for machine learning for many years was computer vision, though it still required a great deal of hand coding to get the job done. People would go in and write hand-coded classifiers like edge detection filters so the program could identify where an object started and stopped, shape detection to determine if it had 8 sides, a classifier to recognize the letters STOP. From all those hand-coded classifiers, they would develop algorithms to make sense of the image and learn to determine whether it was a stop sign. Good, but not mind-bendingly great. Especially on a foggy day, when the sign isn't perfectly visible or a tree obscures part of it. There's a reason computer vision and image detection didn't come close to rivaling humans until very recently. It was too brittle and too prone to error. Another algorithmic approach from the early machine learning crowd, artificial neural networks, came and mostly went over the decades. Neural networks are inspired by our understanding of the biology of our brains, all those interconnections between the neurons. But, unlike a biological brain, where any neuron can connect to any other neuron within a certain physical distance, these artificial neural networks have discrete layers, connections, and directions of data propagation. You might, for example, take an image, chop it up into a bunch of tiles that are inputted into the first layer of the neural network. In the first layer, individual neurons then passes the data to a second layer. The second layer of neurons does its task, and so on, until the final layer and the final output is produced. Each neuron assigns a weighting to its input. How correct or incorrect it is relative to the task being performed. The final output is then determined by the total of those weightings. So think of our stop sign example. Attributes of a stop sign image are chopped up and examined by the neurons: its octagonal shape, its fire engine red color, its distinctive letters, its traffic sign size, and its motion or lack thereof. The neural network's task is to conclude whether this is a stop sign or not. It comes up with a probability vector, really a highly educated guess, based on the weighting. In our example, the system might be 86% confident the image is a stop sign, 7% confident it's a speed limit sign, and 5% it's a kite stuck in a tree, and so on, and the network architecture then tells the neural network whether it is right or not. If we go back again to our stop sign example, chances are very good that as the network is getting tuned or trained, it's coming up with wrong answers a lot. What it needs is training. It needs to see hundreds of thousands, even millions of images until the weightings of the neuron inputs are tuned so precisely that it gets the answer right practically every time, fog or no fog, sun or rain. It's at that point that the neural network has taught itself what a stop sign looks like, or your mother's face in the case of Facebook, or a cat, which is what Andrew Wang did in 2012 at Google. NGS breakthrough was to take these neural networks and essentially make them huge, increase the layers in the neurons, and then run massive amounts of data through the system to train it. In NGS case, it was images from 10 million YouTube videos. Ang put the deep learning, which describes all the layers in these neural networks. Today, image recognition by machines trained via deep learning in some scenarios is better than humans, and that ranges from cats to identifying indicators for cancer in blood and tumors in MRI scans. Google's AlphaGo learned the game and trained for its Go match. It tuned its neural network by playing against itself over and over and over. Deep learning has enabled many practical applications of machine learning, and by extension the overall field of AI. Deep learning breaks down tasks in ways that makes all kinds of machine assists seem possible, even likely. Driverless cars, better preventative health care, even better movie recommendations are all here today or on the horizon. AI is the present and the future. With deep learning's help, AI may even get to that science fiction state we've so long imagined. If you have a C-3PO, it'll take it, but you can keep your Terminator. Thanks to the likes of Google, Amazon, and Facebook, the terms artificial intelligence, AI, and machine learning have become much more widespread than ever before. They are often used interchangeably and promise all sorts of things, from smarter home appliances to robots taking our jobs. AI is a branch of computer science attempting to build machines capable of intelligent behavior, while Stanford University defines machine learning as the science of getting computers to act without being explicitly programmed. You need AI researchers to build the smart machines, but you need machine learning experts to make them truly intelligent. For example, suppose you were searching for Wired on Google, but accidentally typed Ward. After the search, you'd probably realize you typed it wrong, and you'd go back and search for Wired a couple of seconds later. Google's algorithm recognizes that you searched for something a couple of seconds after searching something else, and it keeps this in mind for future users who make a similar typing mistake. As a result, Google learns to correct it for you. While this is a very basic example, data scientists, developers, and researchers are using much more complex methods of machine learning to gain insights previously out of reach. Programs that learn from experience are helping them discover how the human genome works, understand consumer behavior to a degree never before possible, and build systems for purchase recommendations, image recognition, and fraud prevention, among other uses. Chappell went on to explain that machine learning is the fastest growing part of AI, so that's why we are seeing a lot of conversations around this lately. Even though it's a small percentage of the workloads in computing today, it's the fastest growing area, so that's why everyone is honing in on it. Your smartphone, house, bank, and car already use AI on a daily basis, explained Facebook engineering leads Yan LeCun and Joaquin Quayandanero Candela. Sometimes it's obvious, like when you ask Siri to get you directions to the nearest gas station, or Facebook suggests a friend for you to tag in an image you posted online. Sometimes less so, like when you use your Amazon Echo to make an unusual purchase on your credit card. And don't get a fraud alert from your bank. AI is going to bring major shifts in society through developments in self-driving cars, medical image analysis, better medical diagnosis, and personalized medicine. And it will also be the backbone of many of the most innovative apps and services of tomorrow. Artificial intelligence, machine learning, and deep learning have become integral for many businesses. But the terms are often used interchangeably. Here's how to tell them apart. With huge strides in AI, from advances in the driverless vehicle realm, to mastering games such as poker and Go, to automating customer service interactions, this advanced technology is poised to revolutionize businesses. But the terms AI, machine learning, and deep learning are often used haphazardly and interchangeably, when there are key differences between each type of technology. Superintelligent AI takes things a step further. As Nick Bostrom describes it, this is an intellect that is much smarter than the best human brains in practically every field, including scientific creativity, general wisdom, and social skills. In other words, it's when the machines have outsmarted us. Machine learning is one subfield of AI. The core principle here is that machines take data and learn for themselves. It's currently the most promising tool in the AI kit for businesses. ML systems can quickly apply knowledge and training from large data sets to excel at facial recognition, speech recognition, object recognition, translation, and many other tasks. Unlike hand-coding a software program with specific instructions to complete a task, ML allows a system to learn to recognize patterns on its own and make predictions. While Deep Blue and DeepMind are both types of AI, Deep Blue was rule-based, dependent on programming, so it was not a form of ML. DeepMind, on the other hand, it beat the world champion in Go by training itself on a large data set of expert moves. Deep learning is a subset of ML. It uses some ML techniques to solve real-world problems by tapping into neural networks that simulate human decision-making. Deep learning can be expensive and requires massive data sets to train itself on. That's because there are a huge number of parameters that need to be understood by a learning algorithm, which can initially produce a lot of false positives. For instance, a deep learning algorithm could be instructed to learn what a cat looks like. It would take a very massive data set of images for it to understand the very minor details that distinguish a cat from, say, a cheetah or a panther or a fox. As mentioned above, in March 2016, a major AI victory was achieved when DeepMind's AlphaGo program beat world champion Lee Sedol in 4 out of 5 games of Go using deep learning. The way the deep learning system worked was by combining Monte Carlo tree search with deep neural networks that have been trained by supervised learning from human expert games and by reinforcement learning from games of self-play, according to Google. Deep learning also has business applications. It can take a huge amount of images, for example, and recognize certain characteristics. Text-based searches, fraud detection, spam detection, handwriting recognition, image search, speech recognition, street view detection, and translation are all tasks that can be performed through deep learning. At Google, deep learning networks have replaced many handcrafted rule-based systems. For instance, deep learning is also highly susceptible to bias. When Google's facial recognition system was initially rolled out, for instance, it tagged many black faces as gorillas. That's an example of what happens if you have no African American faces in your training set, said Anu Turi, Chief Data Officer for Mint at Intuit. If you have no African Americans working on the product, if you have no African Americans testing the product, when your technology encounters African American faces, it's not going to know how to behave. We're all familiar with the term artificial intelligence. After all, it's been a popular focus in movies such as The Terminator, The Matrix, and Ex Machina. Our bodies collect sensory inputs such as sight, sound, and touch. Our brains take the data and make sense of it, turning light into recognizable objects and turning sounds into understandable speech. Our brains then make decisions, sending signals back out to the body to command movements like picking up an object or speaking. All of the connected sensors that make up the Internet of Things are like our bodies. They provide the raw data of what's going on in the world. Artificial intelligence is like our brain, making sense of that data and deciding what actions to perform. Machine learning and deep learning have led to huge leaps for AI in recent years. As mentioned above, machine learning and deep learning require massive amounts of data to work, and this data is being collected by the billions of sensors that are continuing to come online in the Internet of Things. It makes better AI. On the consumer side, rather than having to adapt to technology, technology can adapt to us. Instead of clicking, typing, and searching, we can simply ask a machine for what we need. We might ask for information like the weather, or for an action like preparing the house for bedtime, turning down the thermostat, locking the doors, turning off the lights, etc. Of course, there are one or two concerns about the impact of AI on our society and our future. But as advancements and adoption of both AI and IT continue to accelerate, one thing is certain: the impact is going to be profound. The idea of creating machines that are as smart as humans goes all the way back to the ancient Greeks, who had myths about automatons created by the gods. In practical terms, however, the idea didn't really take off until 1950. In that year, Alan Turing published a groundbreaking paper called Computing Machinery and Intelligence that posed the question of whether machines can think. He proposed the famous Turing test, which says, essentially, that a computer can be said to be intelligent if a human judge can't tell whether he is interacting with a human or a machine. Today, all of the largest technology companies are investing in AI projects, and most of us interact with AI software every day whenever we use smartphones, social media, web search engines or e-commerce sites. And one of the types of AI that we interact with most often is machine learning. Currently, many enterprises are beginning to use machine learning capabilities for predictive analytics. As big data analysis has become more popular, machine learning technology has become more commonplace, and it's our standard feature in many analytics tools. In fact, machine learning has become so associated with statistics, data mining and predictive analytics that some people argue it should be classified as a separate field from artificial intelligence. After all, systems can exhibit AI features like natural language processing or automated reasoning without having any machine learning capabilities, and machine learning systems don't necessarily need to have any other features of artificial intelligence. Of course, machine learning and artificial intelligence aren't the only terms associated with this field of computer science. IBM frequently uses the term cognitive computing, which is more or less synonymous with AI. However, some of the other terms do have very unique meanings. For example, an artificial neural network or neural net is a system that has been designed to process information in ways that are similar to the ways biological brains work. Things can get confusing because neural nets tend to be particularly good at machine learning, so those two terms are sometimes conflated. If you're confused by all these different terms, you're not alone. Computer scientists continue to debate their exact definitions, and probably will for some time to come. And as companies continue to pour money into artificial intelligence and machine learning research, it's likely that a few more terms will arise to add even more complexity to the issues. An inherent danger of the overpowering influence of data technologies have been mentioned in the Gartner blog post titled "Don't Blame the Technology." In this post, the US has been cited as an example of the dangerous impact of advanced technologies on human society, where data technologies are enabling wealth creation for the few while the other 99% are left in economic darkness. So, the question remains whether such superior technologies and technological research can benefit the masses. The article says not to blame the technological advancements, it is the use of those advances that is upsetting the world. McKinsey's artificial intelligence report suggests that brilliant machines will soon take over the business world, and the daily lives of senior executives will become subservient to these incredible machines. In order to survive and succeed, senior leaders will have to learn to let go of their egos and coexist with smart machines. Top business leaders will still have plenty of opportunity to contribute through confronting exceptional situations and providing solutions that machines can't provide. Too frequently, business functions show a tendency to hoard and politicize information. Maybe the advanced machine learning models of the future will truly break down data silos and pave the way for shared data architectures across businesses. In such an era, even frontline managers will be powerfully equipped with insights from powerful computers before making critical decisions. This way could democratize the distribution and use of data analytics across the managerial chain. The future of machine learning, trends, observations, and forecasts discusses some of these observations further. It is interesting that most articles concerning AI have a skeptical, if not negative tone. This sentiment is also fueled with statements made by Bill Gates, Elon Musk, and even Stephen Hawking, alluding to the possibility that AI could bring an end to the human race. AI and ML roles in preventing cyberattacks have been met with both hope and skepticism. They have been marketed as game-changing technologies, though doubts still persist, especially when used in silos. Their emergence is due largely to the climbing number of breaches, increased prevalence of non-malware attacks, and the waning efficacy of legacy antivirus. For an accurate assessment of the cybersecurity landscape in 2017, Carbon Black turned to the experts. For this research, Carbon Black interviewed 410 leading security researchers in an effort to gauge how non-malware attacks, AI and ML are currently perceived. Business goals include things like increasing revenue and profits, cutting costs, improving operational efficiency, and so on. Businesses are also very interested in increasing customer acquisition, retention, and growth. Customers, on the other hand, have goals like getting a specific job done, such as interacting with friends and family via social media, getting recommendations on movies to watch or items to buy, becoming better organized, and increasing productivity. People also want to use well-designed products that offer a great user experience, ones which are enjoyable, easy to use, and easy to understand. All in all, AI is a very broad field of science and engineering that encompasses many categories and definitions. It is easy to get bogged down by the details surrounding AI, yet it is easy to see the potential of it. It's here. It's here to stay. It's growing at light speed. The sky and beyond truly is the limit, and by whatever standards you judge it, good or bad, AI is going to be awesome. If you enjoyed the video, please like, subscribe, share and leave your comments below. Thanks for watching. Stay tuned for more releases from SciQ.